This week we'll learn how to take METAR observations, do some calculations on them, and make this map of wet bulb temperatures across the U.S. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week, I wanted to take some METARs and calculate the wet bulb temperature because it's been very hot and humid across most of the southeastern U.S., and this is a map that would be very interesting to me on a daily basis, but one that's not available. So we're going to pull in some METARs from the Threads test server. We're going to use MetPy and the calculation functions to calculate the wet bulb temperature, and then we'll use CartoPy to make a map. So let's get started. First thing is from siphon.catalog, we are going to import the TDS catalog object. I'm going to create an instance of that catalog object, pointing to the Threads test server dataset for METAR, which is https://threads-catalog.ucar.edu/text/metar/catalog.xml. It rolls right off the tongue. All right, now that we've got that catalog object, we can see what data sets are there. And I'm just going to go ahead and get the 0th data set for now. And I'm going to download it. So currently we do have to go ahead and download to disk the data set. That's something that is, of course, always being improved upon, but right now we do need to get that file locally to parse it. Then from metpy.io, I'm going to import parse metar file. And we've talked about using parse metar file before, and it's really not too bad. I'm going to need to get the name of my data sets. This is the name that it would be saved on disk as. So this is the 0Z observations for 710. So I got one of the older data sets by getting the 0th, but that's okay. So I'm going to use parse metar file, act on ds.name, which is going to be the name on disk of my file. And parse metar file will run and return a data frame to me. If I look at the head of that data frame, we can see all the quantities that are there. We can scroll over. There's quite a bit of information. We've talked about a lot of these quantities before, making things like our aviation weather maps. One thing we do need to do, though, is go ahead and retrieve our unit information. So the unit information is stored in the units attribute of df. And if we look at that to remind ourselves, it's just a dictionary where the key is the name of the data series and the value is the units that should be assigned to it. What we're also going to do is drop any rows that don't have air pressure, air temperature, and dew point, because we know those are the 3 quantities that we need to calculate wet bulb temperature. So I'm going to use the drop in a method. I'm going to specify a subset that I care about, which is air pressure at sea level, air temperature, and we'll go ahead and line wrap here, dew point temperature, and how I want to drop it if any of them are missing, because the calculation just won't work. All right, so now we've whittled our data set down to just where we can actually calculate the wet bulb temperature. We need to go ahead and attach some units and get to calculating. So from metpy.units, we're going to import the Pandas dataframe to unit arrays helper. And again, we've talked about this pretty extensively before. Pandas dataframe to unit arrays is going to take our data frame, and then the column units which we stored in a variable called unit info. And it will return to us a dictionary that has united arrays. We'll just keep calling it df though. I'm going to import metpy.calc as mpcalc so we can use our calculation functions. I'm going to remind myself what keys are here. Air pressure at sea level, we know we're going to need that. We know we're going to need temperature and dew point. All right. So I'm going to add to this dictionary the wet bulb temperature. And the wet bulb temperature is going to be equal to mpcalc.wetBulbTemperature. I can use Shift Tab to remind myself of the function signature, which is pressure, temperature, dew point. df air pressure at sea level. So there's pressure. Then we're going to use air temperature. We can tab complete that. And finally, dew point temperature. And we see we've got a red parenthesis here because we need a closing bracket. All right, now this calculation is an iterative calculation, and it's going to take a couple minutes to complete. You have to remember we've got a lot of observations to deal with here. So we'll check back in on this calculation in a minute or two. Okay, so our calculation's finished, and now we're ready to go ahead and make a map. Let's see how many points we have here to deal with. So I'm going to look at the length of my data frame, and we'll just pick our wet bulb temperature here, which is really a dictionary of united arrays now. We have about 8,000 points. I'm going to import cartopy.crs as ccrs. I'm going to import cartopy.feature as cfeature. And I'm going to import matplotlib.pyplot as plt. And of course we're going to use our matplotlib inline magic so our figures come up in the notebook. The first thing we need to do with any cartopy map is set a projection or a coordinate reference system. So from the cartopy coordinate reference system module, we're going to use the Lambert conformal system. The central longitude, again using tab completion here to help speed up my typing, is going to be -100. The central latitude is going to be 45. I'm going to set some nice bounds that cover conus. And we'll go from about -122 to -75 and 25 to 50 in latitude. Notice this is a list that contains a tuple. That's what we're expecting when we pass these bounds. I'm going to create our figure. I'm going to specify a figure size of 10 by 8. We're going to add a subplot to this figure. One row, one column, first plot. The projection is going to be our coordinate reference system that we defined. Set the extent. We're going to unpack our bounds. So that's going to unpack that list and give the tuple of bounds that is expected here. And the coordinate reference system is going to be the cartopy coordinate reference system plat curie, meaning that those bounds are in latitude and longitude. We're going to add a couple of features from a C feature. I'm going to add a coastline, and I'm going to use the with scale method of 1 to 50 million. And a line width of 0.75. And we're going to add US states with a line width of 0.5. Finally, I'm going to make my scatter plot and save a handle to it as SC. First thing is the longitude or the x-coordinate, the latitude or the y-coordinate, and the color of this scatter plot is going to be my wet bulb temperature. And I'm going to convert it to 2 degrees Fahrenheit, as that's what we're used to looking at this map in here. The transform, these are latitude and longitudes, so again they're Plat Curie. I'm going to use the hot color map reversed with a minimum value of 70 and a maximum value of 95 and a dot size of 5. Finally, I'm going to add a color bar using my handle to SC or scatter. I'm going to shrink it to 70%. And here we have our map. So there's our shrunk color bar, so it fits the map size a little bit better. And you can see that we have wet bulb temperatures commonly in the mid-70s and into the 80s. So again, these are pretty hot times around here and very humid. I hope that you found this useful and that you'll try calculating quantities from METARS for your next map. I'll see you on next week's MetPy Monday.